Hello friends, and welcome at my channel. Today I would like to explain to you some further ideas about derivatives and limits. Last time we've talked about the different properties of limits, and today we're going to apply them in order to produce derivatives. And I think at the end of the lecture I'll produce a tangent line on f of x equals to x squared, for example, and we will kind of prove that everything we've done is correct. All right, but first of all, let's see if we have f of x equals to 5, for example. So f of x equals to 5. This is a constant function, and if you remember, if we're talking about derivatives, we're talking about rates of change. So there is no change at all, not an average change, not a momentary rate of change. So it's just 5 all the time. If we would like to produce the first derivative doing the first principle, what is the approach? Well, f prime at xo would be a limit. Just remind you, h towards 0. You remember, this is f of xo plus h minus f of xo divided over h. So in this case, we would have a limit h towards 0. Well, this function brings everything to 5. Whether we have f of xo plus h or f of 7, doesn't matter, it's just 5. So 5 minus 5 divided over h. That would be a limit h towards 0, 0 divided by h. That would be a limit h towards 0, just of 0. And this is a constant value. It's not changing. It's not dependent on h, so it's 0. What about the x method for the same function? F of x equals to 5. So if we have a derivative, you see this is the limit x towards xo. We got f of x minus f of xo divided over x minus xo. That would be a limit x towards xo. F of x is 5. F of xo is also 5 divided over x minus xo. And that would be a limit x towards xo. 0 divided over x minus xo. That's a limit x towards xo of only 0, because we divide nothing by a factor which is unequal to 0. And now our value 0 is not dependent on x, so the outcome is just 0. All right, the same result. It's clear the tangent line must be parallel to the x-axis itself. Now we move on. Let's say f of x equals to x. What about this one? Well, f prime at xo would be a limit x towards xo, and then don't forget that x can be written as 1 times x plus 0. So the slope of this line is 1. Maybe it has to mean something. We will see. So what is f of xo plus h? Or I started with the x method, it's all right. Then we have f of x minus f of xo divided over x minus xo. Don't forget, this function brings whatever we put in unchanged outside. So f of 5 would be 5, f of xo would be xo, and so on. And f of xo plus h would be xo plus h in the first principle method. We will see in a moment. But now we can immediately cancel, as you can see. So it's 1. Have a limit x towards xo of 1, and this is just 1. So that's nice. And what about the h method? So the first principle, this is just a limit h towards 0. We got xo plus h. We're not changing anything. Minus xo divided over h. As you can see, those two are canceling out. H towards 0, h divided by h, which is 1, a limit. H towards 0 of 1 would be 1. So it's absolutely the same result. Now let's move on to f of x equal to x squared. What will happen here? So let's start now with the h method, with the first principle. So what does this function do? It squares. Whatever we put in, it squares it. So we put in xo plus h, we square it, minus xo squared divided by h. This is the limit, h towards 0. Now we use the binomial formulas, xo squared plus 2xoh plus h squared. Now I have to move myself somewhere here. Minus xo squared divided by h. And now you see those two are gone. Now we have limit h towards 0. Well, you see, we have now a common factor h. We can take it outside of the parentheses. We got 2xo plus h divided by h. We cancel those two, and now we have a limit h towards 0 of 2xo plus h, and now we have no trouble for h to run towards 0. So the outcome is 2xo. If you remember, I've done it previously in one of my videos visually. If not, just watch the playlist. Visually, I showed you the product rule and the derivative of x squared. It's also possible to show x cubed. After that, things are going to be more difficult. All right, it is x squared now. What about the x method? So f of x still being equal to x squared. Well, f prime at xo would be a limit x towards xo. We got f of x, which is x squared, minus f of xo, which is xo squared, divided over x minus xo, which is a limit x towards xo, x minus xo times x plus xo divided over x minus xo. As you can see, we cancel those two, and we're gonna get limit x towards xo of x plus xo. And now we have, once again, no trouble to put x towards xo, so we're gonna get 2xo. As you can see, the same result, which is also very important here. So geometrically, you see, if we have a parabola like this, then we have a tangent line with a negative slope, a tangent line with the zero slope, and a tangent line with positive slope. So those three slopes are totally different. They have different signs as well. And it's important now for the first time. It wasn't important previously at 5, was everywhere 0. It wasn't important everywhere at x, it was everywhere 1. But now it is important where we are willing to put a tangent line. So let me quickly produce an example. Let us say we have f of x equals to x squared. We already know its derivative is 2x. And what we would like to do, we would like to produce the tangent line. So the point is 2 and 4. So it looks like this. This is the parabola. This is 2, and somewhere here we got 4. And that would be a tangent line. All right. So it should be looking like this. Obviously, if the tangent line we're producing now has a negative slope, I would say something is wrong. But the tangent line t of x is equal to mx plus b, and we know that m can be computed as the value of the derivative at this point. So in this case, m is equal to 2 times 2, or basically f prime of 2, which is 4. So what we already know is t of x is 4x plus b. Lucky me, so no negative value, otherwise I would be in trouble. And how can we compute the value of b? Well, we put 2 for x into our tangent line equation and 4 for y. Well, obviously, if we go through this point A, then not only the graph, but also tangent line totally. So 4 is equal to 4 times 2 plus b. We have to subtract 8. b is equal to minus 4. t of x equal to 4x minus 4. I'm claiming this is the derivative that I have on the graph. Check it on your calculator or on your computer program. I'm pretty sure I'm right. If not, let me know in the comments. Thanks for watching. I hope you learned something new. I'm gonna produce furthermore derivatives of x cubed, x to the power of 4, and x to the power of 5, and then we'll see some pattern. And then we're gonna prove the derivative of the exponential of the powers. So x to the power of n, the power rule of the differentiation. We're gonna show that x to the power of n, its derivative, it's n times x to the power of n minus 1. I know you somehow learned it at school, remember that, but I want you to understand it. Thanks for watching. Stay healthy, don't panic, and everything's going to be all right. See you guys. Bye-bye.